All right, good afternoon and welcome back. We are back again to finish conditional statements, to finish our lesson on conditional statements. Today we're going to start off with a biconditional statement. So you should already know a few: conditional, converse, inverse, contrapositive. But a biconditional statement is a statement that can be written in the form P if and only if Q, where P is the hypothesis, Q is the conclusion. And a lot of times we use biconditional statements to write definitions. And that's because they go both ways. So you can see here you got a double-sided arrow in here. That double-sided arrow is if and only if. Sometimes they'll just write IFF to stand for if and only if. So keep that in mind. But really biconditional means if P then Q, and it means if Q then P, which is why the arrow goes both directions here. So they make really great definitions. So what you got to be able to do to write these is you have to be able to know what the conditional and the converse is. So like in this first example A, here is a biconditional statement. It says two angles are congruent if and only if their measures are equal. So the conditional part of that would have been if two angles are congruent, then their measures are equal. And it's combined with the converse, which would be the reverse of that. If two angles' measures are equal, then they are congruent. And I'm shortening this up a little bit. Instead of using equal, I'm going to use an equal sign. So that's what you've got. You got a conditional, you got a converse. They combine to make a biconditional because it's going to go both directions. Here's another one. A solution is a base if and only if. There's that double-sided arrow we talked about. Sometimes it will be IFF. Again, keep that in mind. A solution is a base if and only if it has a pH greater than 7. So the conditional might have been if a solution is a base, then it has a pH greater than 7. I'm using the greater than sign. Should probably capitalize that H while I'm at it. Okay. Converse would be if the solution has a pH greater than 7, then it is a base. And again, the biconditional is a combination of both of those together, the conditional and the converse. So I said this was really good at writing definitions. So here's a definition: midpoint of a line segment. By the way, we've defined this earlier in the year, but it's the point that divides the segment into two congruent segments. So if we wanted to write that as a biconditional statement, it needs to go forward and reverse. So we may say something like, as a biconditional, a point is a midpoint of a line A point is a midpoint of a line segment if and only if, I'm going to drop in the IFF, remember that means if and only if and only if the point divides the segment into two congruent segments. Two congruent segments. That would be a good biconditional. It goes forward and backward. A point is a midpoint of a line segment if and only if the point divides the segment into two congruent segments. Example 2. A triangle is a three-sided polygon. That's a definition. A triangle is a three-sided polygon. But if we wanted to write it as a biconditional statement, we may say a figure is a triangle if and only if it is a three-sided polygon. And it works both ways. And again, if a figure's a triangle, then it's a three-sided polygon, but it also works in reverse. Converse. If the figure's a three-sided polygon, then it's a triangle. And you can see how it goes forward and reverse. Definitions work really well forward and reverse, your conditional and your converse. So we'll do one more. You can try this one on your own if you'd like to give it a shot. Pause the video. Otherwise, I'm going to go in and just write what I would have written. It says define an acute angle as a biconditional statement. Well, an acute angle is an angle between 0 and 90 degrees. So I might say an angle is acute if and only if, IFF, it measures between 0 and 90 degrees. Again, that statement works not only in the conditional statement, if an angle is acute, then it measures between 0 and 90 degrees, but it also works in the converse. If an angle is between 0 and 90 degrees, then the angle is acute. So it works both forward and backward, biconditional statements. All right, moving on here. Counterexample. Now we're going to start to get into whether a statement is true or false. And we're going to talk about conjectures, which we defined yesterday. But in red, the most important thing to know when you're trying to prove one of these statements false is that the only way it can be false is if the hypothesis is true, and I'm underlining that, and the conclusion is false. That is the only way. Okay? So think about this. If the hypothesis part itself is false, it doesn't matter what the conclusion says. If the conclusion is true, whether the conclusion is false. If the hypothesis is false, the entire statement is true. That almost sounds backwards, but that is the case. Because the hypothesis is usually the condition. And here's an example. If I get paid, I will take you to a movie. Okay, there's that if-then statement. You could even throw then in there. If I get paid, then I will take you to a movie. If I get paid, then I will take you to a movie. So if I don't get paid, meaning the first part of it is false. If I don't get paid, there's been no promises broken, so the statement is true. If I don't get paid and I take you to a movie, I never lied to you. If I don't get paid and I don't take you to a movie, that's also fine. I never lied to you. I've never broken my promise. So both of those would be true statements, okay? Whether the hypothesis is false at all, okay? So like the second example, if pigs can fly. All right, there's your if part. If pigs can fly. So right away, pigs can't fly. So the hypothesis is false, so it doesn't matter what is said after that. The entire statement is true. It does not matter what is said after that. The only way, again, I'll go back up here to the red. The hypothesis has to be true and the conclusion has to be false. That's the only way you're going to get a false out of this. That's the only way your conjecture will be false. Okay? So let's practice this. Determine if each conditional is true. If false, give a counterexample. If today is Sunday, then tomorrow is Monday. So if today is Sunday, so we're going to assume that that's true. Then tomorrow is Monday. Well, if today is Sunday, tomorrow would have to be Monday, so that would be true as well. So this whole statement is true. Because if today was Sunday, then tomorrow would have to be Monday. Okay? All right, let's go to B. If an angle is obtuse. So we're going to meet the conditions. So we're going to assume that this angle is obtuse. If the angle is obtuse, then it has a measure of 100 degrees. Well, that may not be true. If an angle is obtuse, that could have been 120 degrees, 130 degrees, 140 degrees. So we've got the hypothesis is true, conclusion is false, so that whole statement is false. Okay, moving on to the third one. If an odd number is divisible by 2, so we'll go out on a limb, and if you know anything about odd numbers, none of them are divisible by 2. 3 doesn't divide by 2, 5 doesn't divide by 2, 7 doesn't divide by 2. So right away, this hypothesis is false. There is no way you can get an odd number divisible by 2. You can get angles that are obtuse, you can get the day to be Sunday, but you will never have an odd number divisible by 2, so it is false. You can stop right there because no matter what is said after that, this statement is true. You don't even have to look at the second part. Because remember, going back to the red, the only way a statement is false is when the hypothesis is true, but the conclusion is false. So if the hypothesis is false, the whole thing is true. Okay? Even if it says 8 is a perfect square, 8's not a perfect square. So both parts of that were really false. But we said if an odd number is divisible by 2, that's like if pigs can fly, then this will happen. But pigs can't fly, just like an odd number can't be divisible by 2. So it doesn't matter. We'll never meet that condition. Therefore, that statement is true. We are not lying to you because we only said if a number is divisible by 2, which will never happen. Okay? Again, we'll do a lot of practice with that. Now, we're also going to do find a counterexample here. In fact, let's go back to that last one. Because it says if false, find a counterexample. All right, so example B, we got false. The counterexample would be, and I gave several of them, the angles could be 120 degrees. We're going to keep working on that. So counterexamples. Show that each conjecture is false by finding a counterexample. For any 3 points in a plane, that's the if part. If you have 3 points in a plane, then there are 3 different lines that contain 2 of the points. And for the most part, 3 points in a plane like this, there's 1 line, there's 2 lines, there's 3 lines. But, so our hypothesis is true. I can show you an example where this is false. 3 different lines that contain 2 of the points, what if they are collinear? If they are collinear, there's only 1 line. There would not be 3 different lines, so that would be a counterexample to that. Here's another example. This one has to do with the chart. The temperature in Abilene, Texas never exceeds 100 degrees during the spring months, March, April, and May. So we're looking right here. Counterexample, May, 107 degree temperature. We said it never exceeds 100 degrees. It did in May. That would be a good counterexample. Proves it false. Last 2, show that each conjecture is false by finding a counterexample. For any real number, so we got to pick a real number, x. Any real number. You don't know any imaginary numbers yet, so every number you could possibly think of at this point in your life are real. For any real number, x squared is greater than or equal to x. So could you find a counterexample? And my counterexample would be, what if x is 1/2? Then 1/2 squared would be 1/4. And is that greater than or equal to 1/2? No. That is false. So that would be my counterexample. What if x was 1/2? That would make that statement false, because we would have a real number, true, but we would have a conclusion, false. Supplementary angles are adjacent. So we have to have supplementary angles. I'll make this one easy. That's 90 degrees. Here's another angle over here. This is also 90 degrees. They are supplementary angles, but they're not adjacent. They're not next door. They're not sharing a fence. So again, the supplementary part is true, but the adjacent part, the conclusion, is false. You can do that several examples. You could go like 30-degree angle and then just put another angle somewhere else. Maybe we'll do it like this. 150 degrees. Those two angles are supplementary, but they're not adjacent. They're not next door to each other. So a lot of different ways you could do that. And that's it. That's a wrap on today's lesson. So we're going to keep working on our statements. We're going to work on true, false, and writing biconditional.